While snakes basically have the same overall body morph, elongated and cylindrical, some of them do have unique morphological traits. For example, the hood of cobras and false cobras are quite unique. So is the rattler tail of rattlesnakes. Both are traits that belong to a whole group of snakes, but when we're talking about the whole snake group, it is quite unique. Some more exclusive traits do exist though, like this unique tail of the spider-tailed viper. Or, the topic of this video, of course, the quote-unquote tentacle of the tentacled snake. Whether that structure should be called tentacle or not is debatable. I've talked about it in my tentacle video, so you could check that out if you are curious. But anyway, let me bring up the question. What exactly is tentacled snake? Tentacled snake is, of course, a snake. Modern snakes are usually assigned to the suborder rank, suborder Serpentes to be specific, but there might be some herpetologists who use different taxon, perhaps different name or different rank. But anyway, if you don't want to be pedantic, the point is, tentacled snakes are modern snake. They are classified in the Homalopsidae family, which are the Indo-Australian water snake. Not sea snake, by the way. Those are a whole different group. Homalopsidae are mostly freshwater snakes, albeit some tolerate salt water, like Kerberos for example. But that's not what we're talking about. Tentacled snake is a monotypic genus, meaning there is only one species in this genus, Erpeton tentaculatum. Well, as far as we know at least. There is still a possibility that we'll discover a different species within the genus. But anyway, Erpeton means to creep, although they don't exactly creep around. I mean, they are aquatic snakes after all. And even among aquatic snakes, they employ a unique strategy which makes their behavior quite unique, which I'll talk about later of course. Tentaculatum quite literally means tentaculate. Because they have quote-unquote tentacle. Quite simple, right? I did say Homalopsidae is the Indo-Australian water snake family, and naturally, so is tentacled snake. To be specific, they can be found in some inland water throughout Vietnam, Cambodia, and Thailand. I've seen some articles stating they can be found in seawater, which is quite questionable to say the least, because most scientific articles that I've read about them stated they can only be found in inland water bodies. If we're talking about brackish water, sure, but seawater? Not sure about that. I might be wrong though. Do let me know if they can indeed be found in seawater. Anyway, let's talk about their morphology. Tentacle snakes are relatively small, compared to some famous snakes at least. Adults are typically around 50 to 90 centimeters long. As with other homalopsids, their body is slender. Their head is not particularly big but still distinct from neck. Their dorsal scales are strongly keeled. The coloration is typically brownish to blackish on the dorsal and lighter yellowish brown on the ventral. Some of them have dark longitudinal stripes, while some have dark spots or even yellowish bars. They usually have dark lateral stripes across their eyes, although some might only have faint stripes. But of course, the easy way to identify them is this pair of flexible rostral appendages, which is usually just called tentacles. That's where they get their name after all. And they are the only snakes that have this trait. Well, the only extant snake that we know of at least. Even small individuals have these tentacles, so you wouldn't have to worry about that either. If you find a snake that have these, that's most likely Erpeton tentaculatum. I say most likely because there is always a chance that you are looking at an undescribed species of course, which is great for you and for everyone. So, I guess I'll just write the known meristic traits for identification, just in case someone needed. Not gonna talk about it too much in this video because it might be too boring and it's not exactly easy to explain without looking at the real snake. So, back to the tentacle. Surely this unique trait has a particular function exclusive to them, right? Well, yeah, it does. So let's move on to the behavior section. But before that, like I said earlier, tentacle snakes are aquatic snakes. They inhabit lowland ponds or at least slow-moving rivers. The water that they inhabit is typically murky. They swim by undulating their body, which is basically the same locomotory movement that snakes typically do on land. Hence, tentacled snakes could also move on land. They typically surface and go on land to bask. If you see them on land while it's dark, it's most likely because someone or something brought them there. Unlike some aquatic snakes which lay eggs on land, tentacled snakes are ovoviviparous, and they give birth underwater, mostly at least. Female could give birth to 9 to 13 neonates, each around 14 to 17 centimeters long. Tentacled snakes mostly feed on fishes, hence they don't need to go on land to hunt prey either. In fact, they are so specialized to eat fishes. Let's start with the most common adaptation first: venom. Tentacled snakes are venomous, although the venom is not potent enough to be lethal for humans. But it is definitely enough for fishes. At the very least, it is potent enough to weaken the fish so it does not thrash around and escape from their grasp. But still, they do need to grasp the fish in the first place for that to work. Meanwhile, fish are known to be, well, fast, to put it simply. I mean, just try to catch a fish with your hand, especially in open water. It is very difficult. Actually, let's talk about sea start a little bit to prepare for the next topic. So, fishes and amphibians exhibit a certain behavior called sea start. That's when fishes and amphibians detect a disturbance in the water, turning away from the source, hence making a C shape, and then propelling away, escaping from whatever is making the disturbance. This is supported by the presence of Mothner cell, a pair of big neurons on the hindbrain of fish and amphibians. They only need 7 milliseconds to respond, and only 25 milliseconds to perform the C start. Point being, fishes are difficult to catch, so naturally, tentacled snakes, which are mostly strictly piscivorous, need to have some kind of adaptation to counteract this. And here comes the J ambush stance. That's not an official term, by the way. It's just my own way of calling this hunting strategy. So, tentacled snakes catch prey by ambushing fishes. They use their tail to grasp at stuffs firmly, straightening their body while bending their head, basically forming a J shape with their body. And they just stay still like this until a fish comes close to the concave part of the J. Then, they create a disturbance in the water by moving their body. When the fish detects the ripple, it will initiate C start, and that's when tentacled snake will strike. Perfectly bait it into the mouth, basically. Amazing strategy, right? Even if the fish is facing away from the body, it will still work. You know, that's just how C start is. It will always turn away from the disturbance. Tentacle snakes are literally exploiting the innate mechanism of their prey. Even if the prey is relatively far away from their head, doesn't really matter. They will literally propel into the jaw anyway. It takes roughly 25 milliseconds for tentacle snakes to strike. And you know what that number is? That is exactly the amount of time needed to perform the C start. You could say tentacle snakes are perfectly adapted for this. The ones I've shown had been the ideal position, by the way. Of course, it will not happen all the time. But still, even with awkward angle like this, as long as you know the fundamental mechanism, you could predict what could happen. And that is exactly what's happening here. The tentacled snakes predict the movement and just strike to where the fish would be after initiating the C start. So now that you know, you could use this as your answer when someone asks you what is your favorite hunting strategy in the animal kingdom. Although, I'm not sure whether someone would ask you that in your lifetime, so it is what it is. Oh, by the way, of course they will fail from time to time, but with such a perfect strategy, what situation would make them fail? Well, funnily enough, that's when the fish failed to initiate the C start. They fail when the fish failed to react quick enough. That's just how it is with anti-meta strategy after all. So it is what it is. Oh, by the way, it is noted that while they are swallowing a big fish, which naturally will take more time, they wiggle their tail. This is most likely done to distract predators so they could be relatively safe. You know, keeping predators away from their head. Quite clever, right? Now, I have spent some time talking about their behavior, yet still no mention of their tentacles. Where do these tentacles come in then? Actually, let's dedicate a whole section for this, because why not? So, some of you might think the tentacles are used as baits for fishes. But as you can see in the previous videos, fishes don't seem to be attracted to their tentacle, which is why that hypothesis was discarded. Oh, and of course, the tentacles are not used to grasp food. It's quite short after all, and tentacled snakes tend to eat fishes that are larger than their own head, so their tentacles would never be long enough to grasp their prey. So, the answer is, it serves as mechanoreceptor, which might be a boring answer, but yeah, they use their tentacles to detect water movement. What's interesting is, however, morphology-wise, there is basically nothing special about their tentacles. Their tentacles are completely covered in scales, and there is no special structure on it either. It's basically just a flexible protrusion. However, there is a lot of nerve inside. Literally, I mean, not an idiom. These tentacles are important for their ambush strategy, of course, as these enable them to detect the ripple created by the fish, especially when initiating sea start. By detecting the ripple from the fish, tentacled snake could determine where to strike. Not only that though, it helps greatly when detecting prey or for general navigation in low light condition. That's why, even though they mostly detect with their vision, they could still be active in murky water or at night with the help of their tentacles. And yeah, that is tentacled snake. One of the cooler reptiles in terms of adaptation if I do say so myself. Unfortunately, not a lot of people know about their existence. But hey, that's why I decided to make this video. Who knows what we'll learn in the future? Maybe another species in this genus? We'll see. For now, let's just learn what is known. And that's all for now. Oh, by the way, scientists were wondering whether their predictive strike is learned by experience or innately learned. So they did a test to a newborn that never met a fish before. The result was, even newborn could employ the strategy. Anyway, enjoy your day.